Hello everyone and welcome to another member sponsor video. Joining us tonight we have Mr. Logan Frank. How's it going, Logan?
Going really well.
Alright, so this is the first video in a multi-part mini-series. Yesterday on 3D Buzz I threw out a request. I said those of you that are member sponsors, if you're interested in seeing a short Python game put together, let's say maybe over Pong. Let me hear 5 of you speak up right now, and within just a matter of 1 or 2 minutes, we had all 5 requests, so I was pretty impressed. And I talked with Logan about it. Hey, let's throw together just a real quick graphical game with Python. Let's not worry about making it super structured or anything, because we've got a Python class that is about to start, which I'll talk more about in just a second. So anyways, just, throw something together for those out there that are interested in learning Python. They could just follow along as they are waiting for this class to begin. And Logan said, yeah, that sounds great. But then, unfortunately, we weren't able to get to the videos last night. Logan started off putting something together, and I got caught up in the world of Houdini. Now, here we are the next night, and we're about to actually put these videos together. But first, for the member sponsors that are interested in truly learning Python, you will be excited to hear and learn that we are starting a Python course for member sponsors as of later next week. That's when the course is actually going to fire off. And it's going to focus on all things Python, which means we're going to do gaming stuff, we're going to do 3D related stuff, etc. You're going to get a little bit of everything, but the idea is to truly learn the Python language. So, right now, we're just going to have a little bit of fun. The idea is to put together a Pong game. Logan, you want to spend just a second and talk a little bit about what we're going to do in this video?
Sure. Well, in this video, before we get into anything dealing with Pong, we need to obtain Python itself.
Okay.
We need to get the Python interpreter installed and verify that it's running.
Okay.
Once we do that, we need to get some library that will aid us in making the game. I mean, I'm sure there's other ways we could go about doing it, but we need, first and foremost, we need some interaction with Windows itself, because we're going to be making a Windows game. So we need something that will give us a window. And beyond that, we need things that will give us gaming-like facilities. It would be very helpful if we could have a display surface created. It would be very helpful if we could get input given to us. It would be very helpful if we could generate sounds and things of that nature.
Right.
So we're not only going to download and install Python, we're also going to install the PyGame library.
Okay.
That is a gaming library built for Python that allows you to do just that. It gives facilities such as a window that you can use. It gives you a surface you can draw to. It allows things like buffer flipping for flicker-free animation. It gives you input. It also gives you the ability to do sound.
Sounds good.
So what we're going to do in this video is we're going to look at both installing Python, installing the PyGame library, and then we're going to write a very quick test application just to make sure that PyGame is running. We're going to make a small window that has one graphic in it that bounces around the edges of the screen. Just something to prove that PyGame is running and can give us a visual result.
Very cool. Now, we know we have this class coming up later next week. It's going to kick off and go from there. The idea of these videos, correct me if I'm wrong here, is just to demonstrate putting this quick game together. We're not going to go in there and present this from the point of view of, hey, we're teaching complete beginners how to code in Python.
Exactly. This is not an introduction to Python.
That's right.
So some of the things are going to be done just because they're there, because they work.
That's
and
right.
We'll get into the explanations of the hows and whys when we actually get the class kicked off.
I mean, you're going to talk about what each line of code you're putting down.
Oh, sure.
Now.
I'm going to talk about what it is, why I'm using that.
But you're not going to get into specific syntax, like there's no curly braces. The indentation has to be like such, or it's not. We're not going to get into all
exactly.
of
I'm just going to write it straight out. I may explain why it's in use in Pong, but I'm not going to explain why it is in the Python language.
Exactly. We'll be getting into those things in the course. So, once again, for those of you that are member sponsors and you are interested in learning Python, once again, great news. Next week, we're going to be kicking off a Python course just for you guys. All right. So, with that, Logan, let's get started.
All right. Well, the very first thing we need is Python itself. So, to obtain that, we would go to python.org, the official website of Python, and to download it, we'll set up with the latest version, which at the current time of this recording is Python 2.5.2 final. So, if we would like to obtain that, we could grab that link, and under the download releases, since we are running non-64-bit Windows, we would get the installer for x86. So we would get this installer. Now I have already downloaded this to the hard drive, and I've done that just to make sure that no internet hiccups would interrupt this video. So
sure.
Grab that file if you're on 32-bit x86. Of course, there are 64-bit versions, so if you have that relevant system, then of course grab whichever would work best on your own system.
Okay.
And of course, there are also releases for other platforms, Mac, Linux, and so forth. Python is widely ported among many different OSs. Though keep in mind that the videos we'll be recording are going to be on the Windows platform. So where anything would get platform specific, we will be recording from the Windows platform. Though there is no reason that without minimal effort, all of what we do could be made to work on many platforms.
All right.
So, and just to prove that I've got that file, I have a temporary folder set up, and there is the file. So just pretend we have instant downloading abilities. All right. With that, let me go ahead and point out PyGame, and that way we can install the two programs back to back. The other thing we, of course, would need to download is the PyGame library. So we would find that at pygame.org. And from the PyGame website, we would go over to the Downloads section, and inside of Downloads, we have different packages. We have the source, we have Windows, we have Unix distributions, and of course, being on a Windows platform, we would download this version 1.7.1 for Python 2.5. Again, the most current version at the time of this recording. And once again, that file exists here as PyGame 1.7.1 for Python 2.5. And now that we have both of these files obtained, let's go ahead and get everything installed. So I'm going to begin with Python itself. I'll run the Python installer. I'm going to leave pretty much everything default. We'll install it for everyone on the computer. We'll install it to the default folder of C drive Python 25. I'm going to let it install everything that it wants to, and this will include things like the documentation and some test things. So give that just a second to copy all of the new files in. And after we get this installed, I do want to test it before we jump immediately into PyGame. So as soon as this setup completes, and it has in fact completed, I'll hit finish. Now, I want to test out Python. So where would be the first thing to go? If it has registered Python as a link in the system, I should be able to simply go to Start and Run within Windows and type in Python. And look at that, I have a console window loaded, but this is the Python interpreter loaded. Now, if this for some reason doesn't load on your system, take note of this path. Whatever path you installed it to will have a Python executable, and simply running that executable will produce this console window. So if for some reason on your system the shortcuts didn't get set up, you can always run it directly. But now that we have Python, what things can we do with it? Well, it tells us right off the bat we have access to help, copyrights, and so on. But I want to point out just a few things that are actually kind of interesting at the command line itself. First off is that mathematical expressions can be entered in directly. So if I did something like 4 divided by 2, we get a result given back.
Okay.
Or even something in exponents like 2 exponent 3 plus 45. Gives us 2045.
Excellent.
Now, of course, we have pretty much everything within the Python language at our fingertips here. Though, I mean, it may not be convenient to enter a 100-line script into the terminal window.
Right.
But just to prove that we can run something a little bit more complex in an expression, I'm going to assemble a for loop. We could say something like for char in a string. That string I'm going to specify here is a literal as hello world.
We did a hello world app.
Indeed we are. So if I hit enter now, or actually I'm going to put a colon after the end of it. If I hit enter, you see our prompt has changed to 3 dots. If I tab over to place myself within this for loop, I could do something like print char, well, if I spelled it correctly, and hit enter, and then enter again to finish off the for loop. And check it out, it has printed each character of that string on its own line. So it has run a single print for every single character within the for loop.
Very nice.
But what this does do is verify that Python is in fact running and able to execute code. So very good. The Python install is successful. I'm going to exit out of the interpreter now by hitting Control-Z and then enter. All right, now it's time to get PyGame set up. So, of course, here is the installer. We'll run this and hit next, and it has detected the version of Python that we're running. Apparently it has read it out of the registry, which is fine. So we'll let it install into our Python directory of C Python 25. And with that, then we have PyGame installed. So very quick installer. As a matter of fact, if you'll note the file size, it is under 1 megabyte. So
yeah,
very quick
small.
install there. All right. Well, now it's time to prove that PyGame is, one, working, and make sure that we can get some sort of a result out of it. I actually put together a little visual test application. Now, in order to do that, let me point out these graphics I've got sitting here, especially the enemy graphic. The reason to have this is I'm simply going to use this in the test application. I want some recognizable graphic. I mean, not recognizable in the real world sense, because it's just a little spiky ball. But this gives us a graphic in PNG format that we can load using PyGame. This is the graphic that we will in turn draw to the screen. While I'm inside the image viewer, I can point out what the other two graphics are, and that is the little cross and the paddle. These will be used later in later videos in the Pong game.
Right.
So we'll address those when we get into Pong itself. For now, we're only interested in the enemy graphic. So I'm going to copy that, and I have in advance made another folder on the C drive called Python Projects. This could be anywhere you want, even a different drive. This is just a folder that I'm going to use to work on all of the apps that we build from within Python.
Sounds good.
I'm going to paste this enemy graphic here just for convenience, and so that I can use a relative path. And now I'm going to start a new Python script. So what I'll do is I'll make a new text file, and we're going to call this, and just call it test.py. And the Py extension has already been linked over to Python. We could run it, but we'd simply have a prompt that would flash and go away very quickly. So in order to begin editing this, I'm going to use the installed or the integrated IDE that comes along with Python. To access that under Windows, we can right-click on the script and say Edit with idle. Idle is the Python IDE. Now, upon loading that, we get two windows. We get a Python shell, which is very similar to what we saw when we ran Python manually from the command prompt. We can see the same type thing at the start and the same style of prompt down here. So if we were to do any type of printing from within our scripts, we'd see this in a Python shell window here instead of in the actual Windows command shell. So inside of this Python script, let's put together a test that will use PyGame. The first thing to do is to import the PyGame module itself. So we'll say import PyGame. And now I know there are more efficient ways of doing this. You can actually look into that module and import only specific pieces. But just for the sake of simplicity in this test, I'm going to import the whole thing. So next thing I want to do after importing it is to initialize it. So we'll look at the PyGame module and tell it to init. So we'll call the init function. After that, I'm going to start throwing down some variables. I want to put forth variables that will represent the screen width and height, basically our screen resolution. And I'll set width to a value of 640 and height to a value of 480. So I'll have a screen size of 640 by 480. The next thing I'm going to do is have PyGame initialize the display. I'm actually told to use the display and set the mode. Now the key thing to note here is that when we set the display mode, we actually get a surface returned, a surface somewhat similar to a texture in that it has dimensions and it can be drawn to. And that's very key for the screen here, as this gives us our screen surface that can be drawn to. So since I want to store the result of that and get back to the screen later for drawing, I'm going to make a screen variable, and we'll set that equal to PyGame dot display dot set mode, and that's actually a set underscore mode, and we need to feed in a resolution here. So I'm going to put in an extra set of parentheses. Note that I'm not going to write this straight out. So in another set of parentheses, we have our width variable, comma, our height variable. And the reason I put these in a subset of parentheses is the set mode function is expecting a set of values. That is, instead of two individual values. If we had written this out without the sub parentheses, then what we'd be doing here is sending two arguments. Set mode only takes one to begin with. It requires one, but that one argument has to have two items in a sequence. So now we'll take care of our screen. The next thing I want to do is to load in the graphic that we'll use to draw with. And so I'm going to make a texture variable. I'm going to call it texture, but what's actually getting created here is a surface. And that texture variable will be equal to the result of pygame.image.load. And load will take in a file to load from. Since I have an enemy graphic.png in the same folder, I won't have to worry about paths. I'll just leave this all relative, and we'll simply type in enemy.png. and that will be the graphic we load in. Alright, so next thing to do, I'm going to put down some variables that I will use for tracking this graphic's position on the screen, and I'm going to create 2 more variables that will allow me to store a velocity. So that way, instead of having a hard-coded value, I can just specify what speed and direction I would like this graphic to be moving in. But first, for the position, I'll make 2 variables, a position x, and we'll set that to 0, a position y. We'll start that out off at 0 as well. And then for the velocity variables, same thing, we'll have velocity x equal to, I'm going to give this a value of 1, and velocity y, we'll give this a value of 0.5. So we'll move faster in x than we will in y. Alright, moving on from here, I'm going to make a variable, a Boolean variable that I'm going to use for the game loop control. Because the way I'm going to set up the game loop here is as an infinite loop. But I do want a condition under which that loop ends, thereby allowing the script to end. So I'm going to make a variable called gameOver, and I'm going to set that equal to a value of false, because we're running the game, so the game is not over yet. Then I'm going to turn around and make a while loop, and inside of that while loop, I'm going to say while not game over, then we will continue looping. And let me see, let me make sure I correct that misspelling of game over. Alright, now we're set. And yeah, that should take care of the loop.
Okay.
So next thing I want to do inside of this loop is I do want to have a condition under which the loop can end. I want the game, our little game loop here, to watch out for the case that our game was closed using the close button. Now, what happens is when you get things like a close message or when keys are pressed, those are events inside of PyGame. And we can tell PyGame to give us all of the current events so that we can look through them and see if there are any interesting ones. So what I'll do is I'll make an events variable, and inside of that events list, what we'll do is we'll store all of the current events. We'll tell it to give all events that are currently pending. So I'll tell PyGame to, or PyGame.event to run a get. That will return all the events in a list. And there are, of course, different ways you can go about doing this. You can look at them one by one. You can actually filter out for certain events. I like this method because it allows our game loop to immediately address all events that might be there. So now that we have a list of events, what I'm going to do is loop through them individually so we can look for a specific event. So I'm going to make a for loop. So I'll say for variable event in list events. So now we'll have each individual event accessible in its own variable. So what we can do now is we can look at events one by one and say if event.type is equal to a value of pygame.quit, then we know that the user has attempted to exit the game somehow, most likely by hitting the X button on the game's window. And if that is in fact the case, I'll set the game over variable equal to true, as we should now exit the game at our earliest convenience. But if we've gone through the events and we have not found a quit event, then we'll assume that we want to continue running the game loop. And so the first actual thing to do game loop related is to take our position and advance it by velocity. So we'll take our position x and we'll increment it by velocity x, and we'll take our position y and increment it by velocity y. So that way we'll have a small amount of movement occurring every single update, and then having that movement result stored in position x and y. And there's some bounce code I'm going to put in. I'm going to hold off on that for just a minute. I want to get something drawing on the screen first. So what I'll do next is I'll start addressing the screen, remembering that screen is a surface returned by the display setMode function. So if we take that screen, there's several things we can do with it. First, we can run a fill on it. We can tell it to fill with a solid color. And I'm going to fill it with the values, or of a color of black, which is 0, 0, 0. Again, specified as a set, so we have the inner parentheses. The next thing I want to do is I want to actually render the enemy texture, stored here in the texture variable, to that screen texture. So really it's not so much of a render to the screen as it is a texture combine. We're going to combine the enemy texture with the screen texture. So we take screen and tell it to blit, where the texture or blitting form or width is the texture variable. And then the position on screen I'm going to specify as a set using position x and y. So position x by position y. And once we have this drawn, so what we've done is we've just cleared the screen out. We put a texture on the screen. Now we need to make sure that the buffers are flipped, because PyGame will set up a double buffering scenario. So what we've done is we've essentially just drawn to the back buffer. Now we need to have the buffers flipped to bring this to the front. So we'll tell PyGame.display to flip. And with that, I believe we're about ready to test. So let me hit Control S to save the script. Let me hit F5, and we get a window where we see nothing in it, and I see some red in the background in the Python shell, and we have an error. And I've simply mistyped PyGame. Though we can use this to our advantage here. We've got the Python shell telling us that on line 22 there's an error, so I'll right-click on that number and tell it to go to that line within the IDE. And I'll simply correct the spelling of PyGame. And now if we run, and it's asking us if we want to save, there is an option inside of the IDE to make it auto-save on run. As a matter of fact, since I am going to be using that a lot here in the next series of videos, let me go to Options very briefly, Configure Idle, and then under General, under the Auto-Save section, I'm going to set it to no prompt when we hit F5. So that way F5 will first result in a save, then a running of our code. Okay. That just makes it more convenient because you don't have to hit more keys. You can just hit F5 and an unsaved script becomes saved and then run. Right. So now a single press of F5 results in the game, and we saw a texture whiz across the screen.
We sure did.
And just to show some interesting stuff, if I were to not fill the screen, if I were to comment out the fill line, we would get a more interesting, but in a game, more undesirable result, something that looks like a Hall of Mirrors effect. But this just gives an idea of what would happen if the screen were not filled. It is, in fact, necessary to go and fill the screen and blank it out every time, because otherwise we're running a blit to combine texture onto screen, and if we never clear the screen out, then we simply reapply the texture over and over again. So again, just thought that's kind of an interesting effect, and if we do the fill, then we get a proper result. Though at the moment, we're not calculating any bounces, so our graphic simply slides off screen and disappears. So right after we advance the position, let's do some checks and see if our little graphic has hit the edges of the screen. So I'm going to start an if statement and say that if the position x value is less than 0, then we've gone off the left edge of the screen. Or if the position x value is greater than our width. So now what I'm doing is I'm looking at the right-hand side of the screen. As a matter of fact, I can make this a little bit more simplistic. I'll advance this here in a second. So we'll just say if the position is less than 0, or the position is greater than width, where width being the screen resolution, then we will say we've hit the left or right edge of the screen, and we want to reverse velocity in x. So we'll take velocity x equal to negative velocity x. And we can do the same thing. Actually, let me test this one first and watch what happens when we hit the right edge of the screen. So if we run, we bounce off the right edge of the screen, but if you watch what happened, the sprite went off screen and then the left edge. Yeah. So what happened is the left edge collided with the screen, and we would rather have the right edge to make it look visually better. So instead of going for width itself, we'll actually subtract away from width. And what we'll do is we'll subtract the texture's width. So we'll look at texture. We'll tell it to get a rectangle representing its dimensions, and that rectangle will contain a width attribute. We'll check that. So now if we run, we get an error. Get rec. That's probably because that is rect t. So get rect. And if we run, now we have a nice bounce, but we need vertical bouncing now. So that should be very easy now that we have a simple bounce in direction x. What I'll do is I'll copy and paste that. I'll change the other statement to, actually no, I'll just leave that an if because I want to be able to calculate a vertical and horizontal bounce at the same time if we were to hit a corner. But looking in the vertical direction means we'll need to address position y. So we'll check for position y being less than 0 or hitting the top of the screen or greater than, and in this case, we don't want to look at the right-hand side of the screen, we want to look at the height. So height minus texture dot getrect dot height again. If that isn't the case, we've hit the top or bottom edge of the screen, and we'll reverse velocity y. Now if we run and watch,
very nice. We
have our graphic bouncing around the screen.
Excellent.
So very nice looking. And this does indeed prove that PyGame is running because we've got a Python or PyGame window with a default title. So in an actual Windows window we can move around and play with. And it is drawing a graphic to the screen, and that's updating at as fast as it wants to update.
Okay.
in testing, you'll notice that as I close this, the window does not actually go away. If I were to run this straight out, now that I've got a script written for test.py, if I run it, you see we get everything running, but if I close the window, everything goes away. The reason this window is staying here inside of idle is idle keeps the shell session running even after the script itself exits. As a matter of fact, if these are in fact global variables, I may even be able to go to the Python shell and do something like print position x. Position x actually still holds a value. So
nice.
What's happened is the interpreter has kept the script running. If you would like for the window to close, you can drop in a call to pygame.quit. Normally pygame.quit would be called automatically at script end. If you wish, you can call it manually here. So pygame.quit. And now if we run, everything looks normal, but if we close the window actually goes away because now Pygame has uninitialized itself.
Gotcha.
It can be useful for testing some apps. I have noted certain issues when Pygame has to be reinitialized within the same session of idle. I have seen this cause problems in the past. So while convenient, you may want to take close note of this. If you get really odd errors for absolutely no reason, it can sometimes be caused by uninitializing it. Because what's happening there is you're telling it to uninitialize, but the interpreter session has not actually quit. So who knows what dirty data might still be there.
I gotcha. Okay, well, that's pretty much everything we wanted to demonstrate in this first video. Really just getting Python and Pygame set up and verify that everything's playing nicely together. So with that is going to wrap up this video. Thanks a lot.